Welcome to another episode of physics lesson. Today what are we going to see? We'll be discussing about uncertainties in experiments. Alright, probably I will also touch error, systematic or and random error if there is time. Otherwise mainly we'll be seeing about uncertainties. Now, what is uncertainty? Now, some of the students might get confused between error and uncertainty, but both are different. Error is something that arises due to your carelessness, it could be, or you have not taken necessary precautions to conduct the experiment, to get a more reliable answer, or probably there are like environmental circumstances that has affected your reading, you haven't noticed, or you are not in control of, etc., etc. So those are errors that could be rectified at a later time. Okay. Uncertainty is something that you're not able to control, or in a particular experiment, because of your choice of instruments, you end up with an answer that is not a reliable answer, or it is not very close to the actual answer that you are expecting. I repeat, uncertainty could be due to the choice of instruments. Even if you take all the necessary precautions, still you end up with an answer that is slightly away from your expected answer. Okay, let's see how and when it would arise, and what are the ways or methods that you could reduce the uncertainty in experiments. All right, now let's take it through an example. Now here I've just drawn a small box. Probably you're measuring the length of a wooden block, which is almost the size of this. What would you normally be using? You might take a ruler and you're measuring the length. Now the value that I've written it is you measured it and you end up with an answer of say 2.2 centimeters. In another situation, you're measuring say the height of a room, or the wall's height, compound height, whatever, and you have ended up with an answer of 400.1 centimeter. Now both you have used the same instrument, which is a ruler. Now let's see how the answers or the readings are affecting your result. Now in this 2.2 centimeters, will you be sure that is exactly 2.2 centimeters? Can you vouch on that? No, right? Sometimes it may not exactly coincide with 2.2, as I've tried to draw it here. Probably the reading is slightly away from or more than 2.2 or less than 2.2 and so on. Am I right? It may not be precisely coinciding with the reading that you have written. There might be a slight difference in the reading when you're using it. That goes with any kind of measurements. Am I right? You may not be in a position to give the answer stating, okay, this is precise 2.2 centimeters. I've got some other student is measuring, but then she says, oh, it's not 2.2, it's just about 2.2 or just below 2.2, etc. Now, keeping all this in mind, what would be the range of the values that this 2.2 could lie? I repeat, what could this 2.2's range that could be represented? You might understand it better. See, when I say 2.2, it could be from 2.1, right? Just about 2.1 also. One student might think, oh, it is closer to 2.2. Let me write that. Another student might have seen that it is very much closer to 2.3, but it is not still touched 2.3. She would have also written it as 2.2. Correct? So the range could be from just above 2.1 and below 2.3, isn't it? About 2.1. So this could lie between 2.1 centimeters and 2.3 centimeters. Somewhere between this range could be this 2.2. So how do we take into account? The simplest way to represent it is, you can say it's either plus 0.5, half the range, or minus half the range, because your 2.2 is somewhere in the middle. So it could be 2.2 plus 0.5 on the other side, or minus 0.5 on the lower side. So how do I put that uncertainty in that reading? So I hope you have understood. See, there will be an uncertainty in any reading because of the divisions. It may not be coinciding exactly with the reading that you are measuring. So in this ruler, if I use a ruler, what would be the deviation? It could be a maximum of 0.1 centimeter. It could be away from the actual reading. So how do we put it as plus or minus? You take the precision or the least count of the instrument. In this case, the least count is, or the precision is 0.1 centimeter for a ruler. Okay, you divide that by 2, you will end up with an answer of 0.05 centimeter. So this reading could be 2.25 centimeters, or it could also be 2.15 centimeters. So it lies between that range. Okay, so 0.05 centimeters. Getting it? So this is the uncertainty in your measurement. So this, when you write a value using a meter rule, which is the smallest division is 0.1 centimeter, your reading may be away either more by 0.05 centimeter or lower by 0.5 centimeter. Now this calculation or this value that you get it by dividing least count upon 2 is termed as absolute uncertainty. Okay, that's a key term. So how do we find absolute uncertainty? All you have to do is take down the smallest reading that any instrument could measure, which in other words is least count. Take that, divide by 2. That will be your absolute uncertainty in using that measurement. So now see, look at this value when compared to this 2.2, it's like almost more or less closer. But if I measure the height of, as I said, a wall or a compound, which is like 400 centimeters. Now here also, since the device is the same, you will get the same uncertainty. So absolute uncertainty is irrespective of the measurement. All you have to do is precision upon 2 will give you absolute uncertainty. Getting it? Now, so we have figured that out, and then you have used it in your calculation. See, it's just one measurement. Probably in the experiment, you might be using it more than once. You may be combining them by adding it or subtracting it or multiplying it and so on. So how does this uncertainty throughout your calculations will affect your final reading? That you have to calculate and give an answer, and based on that uncertainty, the overall uncertainty in your experiment, the validity of your experiment will be decided. Because see, for example, you are doing your own investigation, something you are coming up with a new idea where you want to present your data to a forum. What you have to do, you have to consider all these factors where you are choosing your instrument, the instruments, how much is the instrument's uncertainty, how you have calculated it or gone through in your experiment by including all this uncertainty. Then the final overall uncertainty will determine the validity of your experiment. Okay, I'll give you a fact that if it is less than 5%, overall uncertainty is less than 5%, then your experiment is like valid experiment, it will be accepted. If it is between 5 to 10, it is still accepted, but then not to a closer what should I say, accurate value, but still they will accept it. But if it is greater than 10%, then you have to consider, you have to do the calculations again or go back and change the instruments or your experimental methods and so on. All right, that is about it. So here all we have looked at is just uncertainty and absolute uncertainty is uncertainty is the deviation of your actual answer from the measured answer that arises due to the choice of instruments mainly. Now let's calculate the percentage and see how the percentage affects your reading. How do I calculate percentage uncertainty? Is nothing but the absolute uncertainty upon the reading multiplied by 100. Okay, I repeat, the absolute uncertainty, I hope you got how to calculate it. Upon the reading multiplied by 100, you will get the percentage. Okay. Now this percentage uncertainty is for this measurement I have written. Similarly for this one, say this is U1 and U2 0.05 upon 400.1 multiplied by 100. Right. You can calculate these two and compare what's the percentage uncertainty in each case. Now if you have calculated, the values you will get is 2.3% and 0.01%. So if you look at it or compare the uncertainties for these two measurements, what can you say about it? This one has got a greater uncertainty than this reading. Am I right? But both we have used the same instrument. But just because your reading is much away from or much greater than your precision or your uncertainty, the overall percentage uncertainty becomes very less. Getting it? So as I told you earlier, see, already you have got 2.3% in this. So if you have done like 4-5 measurements and if you are adding them all, you will end up probably in 10% uncertainty, right? Which may not lead you to a more reliable answer. So the choice of instruments is very important. How would you decide? You will decide it based on the measurement that you are going to take. The measurement should not be closer to the uncertainty or the precision of the instrument. Getting it? Now, is there any way that I could reduce this uncertainty in this measurement where it is almost closer to 2.2 centimeters? Think. You can. What you could do is choose another instrument which has got a lower precision than this. Okay, I've used a ruler here. Instead, I could go for a vernier caliper. What's the precision of a vernier caliper? It is 0.01 centimeters. So what would its uncertainty be? You divide that by 2, you'll get 0.005 centimeter. So this will become 0.05 centimeters, which will give you 0.23%. See how it reduced, the choice of instrument reduced your percentage uncertainty. You get it? So what you have to keep it in mind, or why do we have to discuss about all this? The final result of your answer, if you want it to be much more precise or a valid analysis, a valid result if you want to obtain, then you must keep the uncertainty to be as low as possible. How would you do that? By the choice of instruments. Choose an instrument that is much closer, much away from, or the uncertainty should be very low compared to the reading that you are taking, which will kind of lead you to a lower uncertainty percentage. I hope you have understood up till here. Now in another video, we will see about how to combine uncertainties when you are doing multiple readings, when you are adding them or subtracting them, dividing and so on. I hope you've gotten some idea about how to go about explaining what uncertainty is and also how to reduce uncertainty. See you in another video.